Still integrate it even when we run out of carbon.
Right, I think we might get the meeting underway, although we're still waiting for the guest speaker to turn up, but got a few little things to go through before that. First of all, greetings to everyone, and congratulations to the group as a whole for the EV Expo that was on last weekend. For those that were in attendance, brilliant, and for those that weren't there, well, you have your chance next year. Some great work was done by Bryce, by Paul, by Felix. Rebecca was the linchpin of the event. She sort of held it together and got people moving, even got me moving. So that's a good thing. So I'd just like to maybe speak a little bit on the EV Expo. First off, I'm not sure how many people attended, but I'd say maybe 400-ish. That's a sort of ballpark figure. There was about 11 to 12 stalls, and we had probably 20 bikes or so in the test ride area. So I thought that was quite good. We also had about 30 or so entrants in the show and shine, and several cars in attendance. We had the Volt, the IMEV, the Leaf, the eVolvo turned up and was there, as well as the Crown all-electric bus, the Aurora solar car, and Swinburne's Formula SAE vehicle. I must put a thank you out also to the ATA, whose assistance in being able to look after the financial side. They handled paying of invoices and also putting up registration pages for the show and shine and for stall holders. As far as the budget goes, we don't have a final figure on the budget yet. We haven't sorted that and paid the last of the outstanding invoices. But it looks like that we actually made a little bit of money out of the expo. So I think that's good. Not only was the event a success, but financially as well, it left us in the black, which is great. Thanks to Good Brew, Boraldo and Swinburne for their efforts. Of course, Swinburne for allowing us to have the expo there, and also they helped a little bit with marketing at the last moment. They chimed in, said, "Here you've got an event on," and decided to do a little bit of marketing for us. So that was fantastic. There was a survey that was conducted and voting for the show and shine. So we haven't compiled the survey results yet, but those survey results will be compiled, and then we'll all have that information. That information will also be part that information can be used to help the industry as well. And since all the stall holders helped bring people to the event and create the event, then I think the information that we gathered should be shared.
Does anyone like statistical analysis?
Doug from the ATA said that he'd be willing to do it, but if anyone else wants to step up and do a little bit of stats on about 70 or so surveys that were completed. Okay.
I think this is really valuable feedback that we should be able to push forward on a few different things with, hopefully.
Yeah. The event was quite busy, and I suppose one of the things that we did lack is that we could have done with some more volunteers. We could have done with heaps more volunteers. So hopefully in the future that'll be the case. We'll be able to have more hands on deck to make the event run smoother. And we're probably lucky that we didn't have more people turn up, because it could have been chaos, but it wasn't. As far as the future for the event, Expo 2014, I think that I think it'd be a good thing to go ahead and do it again next year, and to have it as a yearly event. Also to have the Expo linked with the Sustainable Living Festival, so we can piggyback off of that event and use that to increase marketing exposure and bring more people to the event. And also Burundara Council, with more, we might be able to get a grant through them, as well as being able to use their marketing channels. Same maybe with Swinburne, and some more postering by ourselves as well. I think it will help increase attendance in future years, and we could also probably charge a little bit more for stalls, because I think all the stall holders seem to be quite happy with the way it turned out. Some sales were made, and it wasn't just a bunch of rubberneckers, it was people who were really interested in electric vehicles, seriously considering about buying and looking at making choices about which vehicle they'd like to purchase in the near future, from what was on display and what was on offer to be tried and tested. Now that's the Expo wrap up. Now, as far as any other past events that people would like to, just before I get on to that, there's another thing here. As you can see up behind us here, this is the Face Crack Expo page, and we've got some photos of the event. As you can see here, there's Dino Goodbrew's electric trike that carries the kegs to many parties around the city. That's the test ride area. There's Frankencycle, Joe from Frankencycle, the ATA Expo, the ATA stand, and that's too small to see. There's a weirdly dangerous wooden cart, a lot of fun, but a bit of a death trap. And we can see a few of these photos here. Now there's the Tesla, more of the test ride area, the AVA doing their thing. That's new bike. Stealth were there, as you can see. That's a little slider with a little tyke on board. There's Doug from the ATA, and also from the Geelong EV group, who was an absolute champion. Has really helped grease some wheels and get some things moving. There's the Aurora Solar Challenger, electric skateboard. One of those was sold on the day. There's the solo wheel, and being used quite expertly. So it's quite it was quite a good event. You can see there cars and the Crown bus, Formula SAE, Swinburne, the e-Volvo. There, that's right. As far as the winners of different events, there was the best mass-produced car, which was we gave to the Holden Volt. The best converted car went to the e-Volvo. The best alternative vehicle was the Swinburne Formula SAE car. The best mass-produced bike went to the Hiron, brought by New Bike. And the best bike conversion went to the Pegasus Tandem. I'm not sure if you've got a picture of the Tandem. There's the best mass-produced car, the Volt. and I'm not sure if we get to see the Pegasus tandem in these photos. Also, People's Choice went to Gavin Young and his converted Giant mountain bike. I don't know who that guy there is. So that was quite good, and the winners got lovely little rosettes like this. So we spared no expense, as you can see. Brilliant. The other thing I just want to point out is that we've had this page here, which is for the event itself. But for those that are not face crack heads, we've got the ATA Melbourne EV branch Facebook page, which I would encourage you all to join. It's a good way for us to get information out in between meetings, to be able to keep people posted. And there's things like this, have your say on the bicycling strategy for the Bayside area, which is, I think, worth having a look at, and having your say to be able to help put some of our expert opinions into the minds of bureaucrats in that area. So yeah, please join the EV branch Facebook page, as it's a way that we can all stay connected, which is good. So I just want to say, is there any other past events that people would like to speak on? No? Okay. Any future events that anyone's got information on?
I'm looking forward to that Kinglake rally.
Kinglake?
Which I think there's some planning going on about when that might happen. At this stage, and the ATA is still speaking with Darwin from Kinglake, but I'm not sure how they're going to organise the charging. So
Yeah.
yeah.
Oh, there is a future event tomorrow at 12:30. There's a bike rave. So there'll be some speakers on the back of a bike, and a bit of a trundle around the city. Is it?
Starts in Carlton.
It starts in Carlton at 12:30 tomorrow. So any of you who like your doof and also like cycling, you can put the two together. Right. Also, around the garages, any update on garage activity?
No.
Hey, Felix.
In your garage.
It was full of crap. I'm working on it.
You're working on it. Brilliant, brilliant. That's all we can ask for.
My garage is clean.
Excellent. All right, got the broom out. Fantastic.
We're going to start working on a rickshaw some point soon.
Yes, we've had someone approach us with a rickshaw who'd like to get the thing rolling. It was a prop for a Miss Saigon theatre production, and now it's just been left idle for many years. It looks in reasonable nick, but hopefully we can put some power into the wheel and get the thing rolling.
It won't fit in our garage though.
No, it's
It'll be an outside the garage.
it's big and it's quite lovely. Plus, also we're working with Trinity College to produce a winning vehicle for the RACV Energy Breakthrough. They want to put 5 kilowatts in a tri-sled recumbent bike. So that should be great. They should be burning some rubber and hopefully not frying any of the kids that'll be riding in it. So fingers crossed on that one. Right, I think that's me all sorted. Is there any other bibs and bobs that I've forgotten about?
Just a clarification, you said before about the Sustainable Living Festival.
Mm-hmm.
Are you suggesting that you have an expo, as you had last weekend, in the city?
No, it'd be still at Swinburne, but in order to have it as part of the Sustainable Living Festival's activities, so that they don't just do things down at Birrong they have a broader range of activities. So if we can piggyback off of that, then we can use some of their marketing and combine it with that so that we get a broader range of people coming, and we can spread the word about it to more people.
Would you do it at the same time?
At Swinburne, yeah.
At the same time.
At the same time.
Possibly.
You have it throughout the month.
Yeah,
So
the-
probably.
Okay, right.
The Sustainable Living Festival actually goes for about a month or a couple of weeks or a month. So the actual big weekend that they have at Fed Square is only a part of it.
So would you use that as a means of marketing for this?
Yeah.
So
So
you
this,
have, I'm suggesting perhaps some vehicles, just even a small vehicle, if it's after that.
yeah, well, there often are a couple of vehicles down there.
Yeah, well, close to the event, we can work out some more specific strategies, but maybe having an e-bike ride through the SLF might be a good way to bring people's attention to it and go, oh, I like that. There's more. Plus, there's cars, there's buses, there's all sorts of other vehicles as well, skateboards as we saw, and that sort of thing. All right, well, I think I've rabbited on enough now. Now I'm going to bring Felix up here to introduce our...
Want to introduce it for me?
You're going to do it in front of the camera, Felix.
Oh, it's true.
It's for our internet audience. Don't deny the world.
I like to get
But you should acknowledge them now viewing us on YouTube.
Michael Gutteridge, thanks very much, Michael. I met Michael last Christmas. He called in looking for some copper for his projects, and it's a pleasure really to see you back and give us an opportunity in the area that you've been working on solar electricity research. Michael's the owner of the Deep Green Solar Research Company, and I'm sure he's got a lot to say to us and also show us our show the movie. Thanks again, Michael. It's up to you now.
Okay. Do you remember me, Dean?
Yes, I do.
Heady days, weren't they?
They were.
Were you friends?
We'll leave it at that. We went to university together and got into student politics together. Today, after working on this for about 6 or 7 years, it's kind of fortuitous, but today I'm speaking here because today I made I believe a huge breakthrough. I had a meeting with senior representatives of Australia Post and Star Trek Express, and they want me to put together a plan for electrifying their fleets and to run those off of solar power. Whether it'll actually come to fruition, I don't know, but it's been a culmination of a hell of a lot of work to actually get to that point. They can see the merits. I have explained both the advantages from a environmental perspective, which is really a no-brainer, but also from an economic perspective, that once you exceed something like 100,000 kilometres in distance in a light to medium weight vehicle, then economically it becomes cheaper to run than a fossil fuel vehicle based on current fuel prices. And as soon as they saw those numbers, then immediately you're not talking to the people who have an environmental conscience, but the bean counters. And if you can get the bean counters on site, then I'll say, do it. We don't care what colour the vehicle is, we don't care whether it runs on batteries or it runs on cow poo or whatever it is. If it's going to save us money, then that's what we're in this company to do. So that happened today, and I'll start work on that report tomorrow. And I'm also I don't know if anyone saw recently, but the New South Wales Police Force were advertising how they had this great breakthrough, that they took this GT Falcon with a supercharged 5-litre motor in it and cranked it up to 400 kilowatts, and were crowing about how they have the latest, most advanced technology for a highway patrol car. And for quite a few years now I've been designing electric race cars. Not the SAE formula, I do know a couple of blokes who do that, but something to actually put... Do you want me to do this?
Yeah.
Oh, I need my glass. In a sec, okay. But actually there's interest with running them against V8 supercars. We're looking at building something and competing at the Bathurst 12-hour event, and if you can put an electric car against just bog standard V8 supercars and GT class cars that are raced at the Bathurst 12-hour and have the thing running for 12 hours with battery swaps, and it's competitive, then that will get a global audience, and no one will thereafter argue that electric vehicles are just golf buggies. And on paper you can do it. It's based using a Mitsubishi Evo chassis, which is a proven race reliable car there, and pulling the motor out and putting the type of motor that's actually in the car that I'm going to show you, but a souped up version of that. Alright, let's see if we can get some pictures happening here. Right, let me just push one of these buttons. Personalise, endeavour panel control. I've done this on several occasions, so that's looking positive. Looking for something over up there. Now the next thing is sizing. How big? Oh, can you control that?
Can I control?
The size of the image.
I believe that's currently on the second screen. So I think it's the second screen, so I think it's only showing.
Yeah.
It's actually showing the whole thing, but.
Do you want to do that? Do you want to? I think what I want to do now is I bring up personalise. This control can do it as well. Adjust video. Blah blah blah.
What size?
Where are we? Yes. There we go. Now you probably know what you're doing. The other advantage with a highway patrol car that has that's carrying around something like 20 to 30 kilowatt hours of power is you can build a very good electromagnetic pulse gun. And so if you're chasing someone and you get within 50 metres of them and you'll close that gap extremely quickly with a high-powered electric car, you then just give them a microburst of radiation, of non-ionising radiation, and it fries all the electrics in their car. So no more high-speed pursuits to dangerous, things like that. You can actually just zap a car. You can also, if you wanted, you could put in a coil gun. So you have the ability to have variable velocity ballistics. So you can send tear gas, rubber bullets, whatever you want to do. This is the type of thing the police are interested in because they have more control over a particular situation. I don't pass judgment whether police are good or bad. I pass judgment that their cars are burning fossil fuels and they shouldn't do that. Alright, so we're going to have what, double movie playing, are we? That might get a bit confusing. Oh, we don't want it off. There we go. Well, unless you guys like that, you have like 3D glasses or something.
Yeah, other side.
On the other side. No, this side.
Now, will this... You've got something to get the volume out of this?
Here.
Very good. Front. So it's just turn up the speakers out, isn't it? Okay.
We should apologise to all the internet viewers for the fact that Melbourne traffic this evening was shocking and everyone arrived a bit late tonight, so hence we didn't have everything all queued up and ready to go.
I'm glad it wasn't just me that was suffering that.
No, I think it was all of us. I think Adrian was here on his own until 5 too, weren't you?
Yeah. Oh, 10 to.
I don't normally drive out the side of town. I didn't know whether I'd done something wrong or not, but it was horrific. Oh, how's that music and everything? I should say that before I started building this car or working in this area, I was actually a climate scientist with the Queensland government, was doing a PhD on paleoclimatology, and I realised that, and I also did research into alternative fuels for the Queensland government and wrote some reports for them and for the federal government on Australia's energy futures, and I looked at every possible scenario to take from where we currently are to some kind of sustainable future, and the only thing that was really going to get us there without a huge disruption was electrification of the whole transport system. And that's why I started small and slowly build up to the point where I currently am. Okay, I'll shut up and we'll play this. Made in 2009. In Australia, over 1 million new cars are sold each year, and of that, most of them are imported. And today, all of them have relied on non-renewable fossil resources. Due to the nature of the internal combustion engine in those cars, they require extensive servicing and maintenance, but they have a limited life, something like 10 years, and thereafter they end up in a place like this. For every litre of petrol burned, 2.3 kilograms of CO2 are released into the atmosphere. Now, a rear-wheel drive car runs at about 20% efficiency. Therefore, 80% of the valuable energy that's in petrol is lost as heat, noise and pollution. So the road transport industry today has been a one-way street towards resource depletion. In 2004, my company, Deep Green Research, started to look at solutions to this problem. We looked at what technology was currently available and what was going to be emerging in the very near future. And it seemed that electricity was the best solution to road transport given the way the world is currently structured. Now, we always will need petrol and diesel into the future, but given that most driving in cities on short commutes, then the EV is more than adequate to the task. The pinnacle of EV technology can be seen in the solar cars that come from universities and engineering companies from around the world. They bring them to Australia and race them across the inland deserts in the Global Green Challenge. So this was the model we used for our electric vehicle. Deep Green Research contracted former solar race participants and components manufacturers and got them to upscale their technology to be used in a full-size family sedan. We also thought we'd pay homage to the origins of this technology, so we entered the car into the 2009 Global Green Challenge.
It's even weird, it's different again. What's the zero? That's the town's here now. I don't understand why the other line meter isn't measuring anything. What is that from? Well, now the other pack's disconnected. It looks like there's a really weak short between positive and the chassis. Yeah. Well, I can't see anything in there, but we can actually do that. That's an interesting. Leave that down. you certainly will be short to build batteries or something.
The team at Brisbane-based company Tritium builds solar car controllers that are used by the majority of teams from around the world. David and James, the founders, have been doing this since their days at the University of Queensland. They have a keen interest and expertise in building solar cars and EVs, so they're the obvious choice for development of Deep Green. We also used Tritium to develop the battery management system. This was to ensure optimal performance and safety. Ultramotive also have a history in developing solar cars. They've in fact been working on a revolutionary, ironless, rare earth magnet, series parallel wound, in-wheel motor for an EV. It puts out about as much torque as a V8, but it only weighs around 40 kilograms. In comparison, the V8 weighs somewhere near 200 kilograms. They achieved this by building the motor out of polymers, aluminium, carbon fibre instead of iron. Ultramotive are also responsible for other work on the car, including making the battery pack operational, installing switching gear, and installing the air conditioning system. Although the best solution for an EV would be to build it, we didn't have either the time nor the money to do this, so we decided we'd use a donor chassis. We chose the Honda Civic because of its size, ergonomics and build quality. People often ask us if Honda gave us any assistance. The answer is no. We just bought the car off the showroom floor. If we look at the cost differences, we find that off-peak coal power costs about 12 cents per kilowatt hour, whereas green power costs around 17 cents per kilowatt hour. This equates to $300 versus $380 to run a car 15,000 kilometres. A petrol car costs around 10 times this at around $3,000 per year. Furthermore, when vehicle-to-grid technology becomes commonplace, people will be able to sell their excess power back into the grid during peak times and thus offsetting the cost of running their cars. This will also negate the need to build more coal-fired power stations. Often critics will say that an electric car is just transferring emissions from the tailpipe to the smokestacks of a coal-fired power station. However, if you do the sums, you find that the EV only produces about 50% of the amount of emissions. A truly green transport system wouldn't use coal-fired power at all. In fact, it would use green renewable power, like solar and wind. By doing this, we'd also create a stimulus for more investment in green power. We've built an electric car in Australia on a limited budget, on a short timeline, and basically anyone can own it. This is the story of the EV, Deep Green, and its journey.
Okay, James.
I'm just buying the software up on my laptop.
How will that be?
Well, I'm trying to push out first.
Yeah, just push that.
Okay.
Things are crazy. Okay, you ready? Yeah, it's up.
I didn't get a free charge on this. That could be the sense inside free car control.
But that's all completely isolated from the other side.
Yeah, it's up.
I didn't get a message from the free charge control.
They both came on.
Yes. Try again.
I had voltage on the controller.
Yeah. Haven't been told that the free charge is finished.
Yeah, I measured the voltage. Well, can you just ignore that for a moment? Just get rid of that check. We're going to test this. Oh. The other thing we're going to have to change is the I think it's only got 50 amps for the 50 kilograms for the mass of the car too. So it's going to be pretty gutless trying to ramp up the current. Sorry? Yeah, you're going to have to change that number. Can you do it on that? It's all good.
What do we do? Drop it down and see if we move.
No, 100 amps to move forward, probably right. It's in parallel, if you remember. That's sort of what I expected to be partly gutless. And you know, it runs fine connected to the laptop on the bench. What's new in the car? And you know, I've done this before with the NSW, just dump the laptop in the car and let it run, and it ran for hours. Well, if we put it on the place, we can drive it straight from the laptop and make sure there's no issues there. Yeah, let's just do that. Because we can drive against the brakes, then you can sit in the car and brake it, and only drive it from the laptop. Make sure we're getting that 100 amps out. Surprised the meant to walk with 20 amps actually.
We've covered nearly 3,500 kilometres in just over 3.5 days, so everyone's really worn out. Just got the registration done in Concurrent, and it was a huge relief. We left Brisbane on Monday without a registered car, waiting for the paperwork to go through. So that's one weight off the shoulders. When we get to Darwin, we've got to get the car to a workshop, to get a wheel alignment, balance. We need to fit some new rear springs. Then we've got meetings all afternoon with the race organisers. It's going to be full on. Fortunately, we haven't hit any animals. We've tried not to drive at night, but we're probably going to be driving through Silver Port till about 8 o'clock at night. So we just have to take it easy. It'd be a good idea to get a good night's sleep tonight. And then Saturday at 12 o'clock we start the race. Well, mate, we've actually made it. Well, we've just about made it. Let's pick up and just roll. We're at Hidden Valley Raceway, and it's the day before the start of the race. The car is yet to complete its maiden run around the racetrack, and we still have to pass scrutineering before we run out of time to qualify.
We're pre-charging through these resistors, aren't we?
They can cause any faults once they come off. I mean, nothing changed when I took them off. It's when I took the sense line.
So we should be able to plug out to exactly the same effects as what you just saw, basically.
Yeah, that's true.
That'd be a good check. Let's try that, just in case we disturb something else in there while we're doing it. Where'd that go?
Spent a lot of time bleeping out words.
Okay, well, let's pull that box out. Yeah.
Luckily, we got the car onto the track at sunset, and even though there were some remaining glitches, the car ran sufficiently well to qualify for the race. This was the first time that the car had truly been driven, putting all of the complicated systems to test. I've been working on it for about 4 years. The development of the car has only occurred really in the last 12 months. All that was laying all the groundwork and putting in applications. The state government's been really good. They've kicked in $135,000 for the development of the car. It's sort of called QSET, Queensland Sustainable Energy Innovation Fund. Queensland Transport's been very helpful in fast-tracking all of the approvals and registrations and everything. Brisbane City Council's behind us. No, we just don't qualify. It's set up to help the existing motor vehicle industry. It's actually not set up for full innovation for new startups or anything like that. It's basically set up as a perverse subsidy for an industry that didn't read the writing on the wall.
Here we are running an event which is supposed to be educating you about the whole alternative fuel industry and the green challenge. We've got no federal government funding this at all.
And this is the flagship event for promoting
in Australia
the future.
I'm like bitching in front of the camera.
The Global Green Challenge is being presented this year in two parts, the Eco Challenge and the Solar Challenge. We are doing this is something very special. This is a second all-electric car. I notice its original manufacturer's badges have been covered up.
Yeah.
A problem with the system. There's a computer glitch in there somewhere. It could be software, it could be an earthing problem, and that then has caused a cascade of problems. It's just unsafe to continue on the car until the problem's fixed. Then we'll have the car running until it should.
That's a resistor.
We're going to train the car to Catherine. Work on it properly for the night, half the course, really. These things happen, it's not a tested car. And at least we learned one lesson, and that is you can't cycle on and off the pre-charge circuits without having some kind of consequence. Yeah, we know what the problem is. We have the facilities, the equipment to fix it. So it's not like a race is over by any means.
Last year we had the same problems. Just go to all of them to least fixable, and we'll just be back on the road.
It's hard to be happy in this heat, but well, it could be a lot worse. I suppose that's the best way to look at it.
Last night, I think the number one priority was to get the pre-charge circuit back up and running, which is what we had a problem with yesterday. That involved swapping out a couple of components and replacing them with new ones, but also had a few changes in the software to make it a bit more robust so that similar thing wouldn't happen in the future. Today's length is pretty long, and even if we could get in the charge in the middle, it's uncertain at this stage whether we'd be able to cover the full distance, but ideally I think if we can just get a bit more confidence in the vehicle and get some more kilometres on the clock, then it should be in a good condition to try for a couple of the other stages later on.
Well, so that's an absolute profile drive.
Fantastic. It was assembled enough for the trailer, not for running on the track, basically, the time it's really rough. Yeah.
What's a good effort just to get down and get
So, Robert, great. Yeah, that's how well.
It's using one of those Julian wave sculptors, so it's a company I'm from actually.
Oh, really?
So that's what's on all the solar cars. Yeah. Well, not all of them, but I see a lot of them got this feeling. Yeah. That's sort of was the proving ground for the technology. The solar car controllers, you know, are very mature product now. Certainly the majority of things are using it. And then we've just sort of scaled everything up to 10 times the power. And they're fairly similar size. For this? For this, yeah. Okay. And so this is our new product, and this is the first car it's been in. So this is part of the idea for us is to see how it performs and really iron out any wrinkles there before we release that more widely. What are the chance, no matter what sort of engine they're running, it seems like 75 or 80 is the most efficient. I think that's the sweet spot between having too much aerodrome and just going too slow in that stage. Yeah. Yeah. See you on the road. Yeah. Yeah, right.
Not only the first 100 days on electric, it's the first 100 days this car has in it. So the battery voltage drops rapidly at the start and then runs fairly flat in the middle and then drops rapidly again at the end.
Until we actually do that for the first time, we don't know what range we're going to get out of the car. And this is the first time we've gone even remotely near running the pack down. So the idea is to put a bit more charge in it now. That'll give us, definitely drive all the way to 10 Creek without running flat in the last half a K or something.
Going to keep the current between, I don't know, 30 amps and 80 amps or something. I don't know, it's just like a really boring computer game. Like there might have been one or two batteries, because we've got 107 batteries, so there needs to be one bad battery to make everything really painful.
Willie's garage is down the road. Guys are there working on a boat, and they've got 3-phase power. I spoke to the guys working there, and he said, "Yeah, I don't think it'll be a problem." But I think we'll scrape together a 6-pack and give it to them or something. The car's been running really well. They've basically solved 2 problems, and the third problem they have bypassed what's causing a fault. So we're just doing the calculations, and under ideal conditions, we could be achieving up to 300 kilometres range on the car. And if that's the case, then tomorrow's stage, we can do it within the allotted time frame. We can do it in 2 legs, and we charge in the middle. But we would be putting in a really competitive stage, and we'd be doing that on effectively 0 emissions.
Speed you going to get like?
They're probably around 80 or 90. I think we'll do 140. These cars going pretty.
Here's the prototype. It's prototypes are notorious, but this car, I think once it's ready ironing out all the problems, it'll be sweet enough. I mean, the challenge tomorrow is can we drive it all the way to Alice Springs with 1 stop for a charge? That's a big run we're going to try and do, and whether we make it, I don't know, but sounds a challenge.
Day 2 is a lot better than day 1. We did something like 150 kilometres this morning. We didn't fully charge the car last night because the guys were working on the electronics for the car. There are still limitations on what we can do with regards to rate of acceleration. These things aren't inherent problems, they're just teething problems, and we'll sort that out. But we don't have enough equipment out here in the field with us to be able to comprehensively solve these things. So we'll run with the car how it is, which is suitable for this race. But once we get it back to Brisbane, we will fix those other little problems. The average speed of the car is around 70 to 75 kilometres per hour, which is around the same speed that the other eco-challenge people are doing, because everyone's, of course, trying to conserve energy or fuel. It's nice to be in a place where there's a bit of green, given how dry and dusty it's been. Stopping on the side of the road, loading the car onto the trailer, having to lie in the Red Bull dust, and then drive for 500 kilometres sweating. Yeah, it's nice to have a bit of greenery and a bit of civilisation.
perfect timing. Forget that, that's it. Can you believe that? We arrive, generator arrives. Right. Let's go.
Quickly on one side, technically on the other. Without charging, we're going to then hook up to the big industrial generator that Tesla people are using. They can charge it probably twice the speed that our smaller generator that's in the Land Rover can charge at. So we've had a really good run today. Firstly, in the distance that we've done. Secondly, in the timing, because we got here just before the generator turned up. The generator's going to be here for approximately 4 hours, so that allows us to get a really good charge in to get all the batteries balanced. So it's basically at its optimal state before we start tomorrow morning. We should be able to achieve 300 kilometres. Just going to reset this and we're just going to be coming up here.
My name's Simon Hammond. I run a company called Adelaide. What I'm doing at this event is running a thing called a Tesla Roadster, the world's first production high-performance sports car that you can see behind me. And part of the exercise for us is to see if we can drive this car successfully from Darwin to Adelaide. So far we're doing pretty well with it.
Yeah, I mean, we're going to come up with our target 4 hours to see what I mean.
Well, that's good anyway, because we want to travel slow as well.
Yep.
We really want to look through kilometres out of that. We can get 300 kilometres out of it. That'll be the big money we'll be hanging on.
Right, exactly. Yeah, good for 300, you know, every time.
Yeah.
We're going to try to want to go tomorrow because we need to get a number of 100 watt hours per kilometre. So see if we can do it. And it's just a matter of speed. Again, no tailwind it'll work. No tailwind, I think I'm just going to sleep in and have breakfast. Because it's based on all these chassis, it's a very tight vehicle. It's got no skull shape for mimic converting, and it performs beautifully. You know, it's a sports car. It's actually a sprinter. What we're doing in this exercise is trying to do the opposite, of course, trying to go a long way. So it'll do 0 to 100 in 3.9 seconds, but we're certainly not doing that on this run. So we'll run the battery out.
Yeah, well, the cars look great.
That car's been changed.
Yesterday, right? If we did Adelaide and Melbourne, an electric car, and we had a brunch and an early dinner, and it works. That's amazing.
It all went really smoothly. The car didn't have any glitches. I mean, there's the known couple of things that we want to fix, like if you use the wrong TV area on the TV, you won't pick up any reception. I guess that's what's happening in the car. Some parts of the car aren't getting any reception from other parts of the car.
Well, they're actually still getting over yesterday, right? Adelaide and Melbourne, it's an electric car. It's just fun to be out there. The leading total cargo classes were about 20,000 a town. Oh, it's that time up with your business on. Yeah. Yeah. I think it's the evolution. Controls in those salt cars are sitting in that. Right.
Yep. Okay, we've had Taylor Springs. We went 240 kilometres from Tennant Creek. We drove it in over the top. Power through the traffic lights to the Crown Plaza Hotel. What we did today, 240 kilometres, we were actually doing up to around 80 kilometres an hour. So by reducing the speed, just like with any vehicle, you improve the range. Yeah, very excited for tomorrow. I think we'll do the 300 k's, but not only that, I think we'll exceed it. So we might even get up to 320, 330 k's, which is really quite amazing given the size of the battery pack in this car the technology that we're using. They're not the most advanced batteries to use. But all of these gains have come about because of good design with regards to the motor, transmission system, and the control electronics. So we're now confident that they're all running at really high efficiency, including full build and then being able to come on and race. So all the race expenses is somewhere around $400,000 budget. The Tesla is in the tens of millions of dollars to develop that car, fine-tune that is developing it to a production stage. But the Tesla's had a lot of really clever people and a lot of money put into it. We've only got the clever people and a very small budget. No, there's not really rivalry. It would be nice to stick with them as long as possible, but they're two different types of cars on two different development budgets and targeted for two different markets. And really, what's good for Tesla is good for us. What's good for us is good for Tesla. It's the first time I've actually driven a car that I owned for a year. I never even took one for a test drive before I bought it. I just bought the car and came over the telephone. From a driving perspective, it's like driving a comfortable, modern car, and it's quiet. Tonight, we will take it easy, relax. We've got in early for once. We'll probably give the car a wash. We'll have a few beers, and we'll talk about how happy we are with our results.
They just put a little bit of tape over the charging plug to seal it, so it can't be accused of falsely charging during a trip this morning.
Across the South Australian border, so we're in northern South Australia now. It's a lot further than we expected the car could ever do. Really, the car's not designed for this long distance work. Think about it as having a small fuel tank. So the efficiency of the vehicle is really quite astounding. We followed the Tesla up to this point. The Tesla has continued on. They're hoping to exceed 500 kilometres, but they've got a lot larger battery pack. So I think used to come, people will worship us and worship this spot. In fact, there'll be a pilgrimage to here.
This point history was made.
It's quite ironic that there's a broken fan belt next to it.
Yeah, that's good.
That represents the end of the that's right, the end of the petrol era and the beginning of the electric era. Oh, get in there. That's way. Then it's used as nose, firstly behind bakery, and bakery just happens to have 3-phase power, which have your own bakery, certainly friendly enough, helpful enough to let us charge in their bakery. So we're going to get a couple of hours charge here, and then probably go to the Tesla charger afterwards.
This is not endorsed by Cross Bakery.
We arrived at Port Augusta last night, and it was really a sight for sore eyes after travelling all the way from Darwin and having quite hot, harsh conditions. And even though the outback is lovely, there's something about arriving into a town and having still water and fishing boats, and especially at sunset. It was a really beautiful sight. Wakefield. They just happened to have a 3-phase power outlet, and they were nice enough to let us use it. We've actually been amazed at how easy it has been to access power, especially 3-phase power, all the way from Darwin to Adelaide. If we hadn't known this, we probably wouldn't have carried around a 200 kilogram diesel generator in the back of the Land Rover. You learn these lessons. We expect to probably be consuming something like 1.5 litres per 100 kilometres if you were to do that in a petrol equivalent. And for a car that weighs 10.5, basically the same as a Commodore or Falcon, it's just phenomenal efficiency. We are data logging all the information from the computer in the car, so we will know exactly what our top speed, what our average speed, and how many watt hours per kilometre we've been using. It's pretty barren, but around where the mining's happening is like a lunar landscape, or a giant ants live there or something like that. Coming south from there, go through wide open spaces around near Woomera. I don't know if any of the crew would actually see that kind of landscape. Not only Lake Hart, but many of the other salt lakes that you can see across the distance are really quite a surreal landscape arid outback Australia.
So we're just getting towards the end of the highway part of the trip, so going to make a change to series windings from parallel, which is pretty much like putting it into a lower gear. You get more torque, but you get a lower top speed.
Slight little problem.
Coming out of the green line,
I'm Caleb Walsh. I'm recently graduated in engineering from the University of Queensland, and I'm working for Tritium. Yeah, the car's been really amazing. I think it's impressed everyone. Great little car. I really like working for Tritium. I've learned a whole lot during my time and on this project, and yeah, really feel like I'm doing something.
Still high? Yeah. Quite a normal car. Everything alright? We've got to stop at 8 k's an hour. They've had a grid stop, restart. So you're going to try and do about 75? I think we'll keep it at 70 for the most. That will let us let the passport come over and it's still over. Has there been any change for 1 hour per kilometre? It's doing negative 24 right now. Negative. Oh, that's good. It's going to be charging. Right, that's right. They missed out with the big phone number. What? Like this. Yeah, well, yeah, I said the airbag.
This is the first stage where we have started at the official start point and finished at the official end point, from Port Augusta to Adelaide, covering almost 310 kilometres in 2 legs and charging the car in the middle.
The technology is top rate, actually, and you have to compare the performance of their system, the Tesla system, to know that it's a top rate system. It's expensive. Can they now attract investment to develop that fully functioning product?
I think it's a testament to the design of the concurrent car at the moment. The fact that we just formed on the road with very limited testing and it all just worked together and actually make this race. The car's designed for city driving and 300 kilometres range is well and truly off-road.
The Tritium and the Ultramotive guys, they are exceptional engineers, and what they produce is something that is so difficult to do and so clever to really respect their abilities. I think they've done a great job. Challenging conditions, low budget, fantastic technology, and they've got it working.
It's a relief to be here, but I must say, absolutely worn out. So it's a bit hard to enjoy it at the moment. Tired, worn out. The car looks great actually. The car's quite dusty, and been watching it intensely driving through the outback, the dust, the dry, and then to see it on green lined city streets. It's kind of a bit strange. It's almost like it doesn't belong here. Unfortunately, there's no power supply here to charge up the car. It's a bit crazy. A couple of electric cars in this race. The organisers don't have any power supply for us here at the marshalling area. Both Trivium and Automotive have done a fantastic job, not only in putting the car together, but also in maintaining the car and monitoring all the systems. So yeah, they've worked really hard. I should probably load the car. Excuse me. Meet up on the road and then the front roof cut out a little bit. I'm pretty sure we'll make it pretty silly. Okay, we made it. We're here in Victoria Square at the end of the race. To have a car that wasn't ready when it went on the trailer and was basically fixed just the day that it had to qualify, then 20 minutes out of Darwin to have smoke coming up from under the bonnet, and then to finally get down here and complete it. Just an amazing event. We've got 10 engineers and electronics experts with a minimum of a master's degree who have kept the car running. The guys are obviously blowing off a lot of steam, throwing as many people as they can find into the fountain. I suppose it shows enthusiasm and lightens the mood along. The atmosphere is great. So yeah, I think they're all pretty impressed with their achievements and the whole team's achievements. The technology that we've already got has proven itself suitable for commercial application. We still need to do a little bit more development work to make it bulletproof so you can actually hand it over to an unqualified person. But the design of the technology, the efficiency of how it runs is certainly up to the task. Yeah, electric vehicles are here.
We have an award for deep green research from Queensland. This is another example of practical technological spin-offs from solar cars. Beautifully engineered aftermarket conversions for pure electric car. The engineers behind this, possibly the most energy efficient car in the whole thing, earn their experiences with solar cars such as Sunshine, Mad Dog, and E-Pod, all contributing to the success of Deep Green, and we wish them well in their future endeavours.
We're at the Adelaide Convention Centre. They've just had the award ceremony. We won the award for small electric vehicle. I think it's the first time that electric vehicles, both Tesla and ourselves, have won awards. All the participants in our team are really happy with what's been achieved. So it's a major milestone. It shows that the vehicle's reaching maturity and that they're serious contenders now.
study has demonstrated that on a small budget and a limited timeline, that a world-class electric car to be built here in Australia can be driven in hazardous conditions and can achieve a range exceeding 300 kilometres. The challenge now is to make this type of electric vehicle conversion cost-effective for operators and the general public. To do this, significant investment needs to go into the manufacture of the motors and the electronics. I believe that conversions could be done for less than $50,000. So when total cost of ownership is taken into account, this works about the same as a petrol or diesel equivalent. There really is no economic reason, and certainly no environmental reason, why government and commercial fleet operators shouldn't start including electric vehicles in their fleets. Initially, these vehicles would be used in urban areas, but with time, as technology advances and things like swappable batteries become commonplace, they'd also be used in regional areas. A decade ago, commentators were saying that the electric vehicle had been killed off, but I think we've shown that 10 years on, they've re-emerged both stronger and more exciting than anyone could have ever imagined. I now have to get back and work on the next car that will be entering into the Global Green Challenge. This time we hope to exceed 700 kilometres in a car that's the equivalent to a 4-cylinder that only costs around $20,000. The future really is electric.
Run us through the end. So there's significant contributors that really should be acknowledged. This was put together by students of Gutteridge University. I had a chat to the lecturers in the film, Department of Film and Production, and so look, if I pay for a group of students and pay for all their equipment, they want to come on a trip, make a movie for me. We did it. Queensland Government showed a lot of foresight. Biggest financial contributor came from Japan. And our Premier of Queensland, who actually canned the funding program that this started. The guys who made the film. It's amazing actually the flow-through effects of things. Oops, I don't want to play it again. So many small groups that actually make money out of this. There's like all of the component manufacturers where possible we tried to use local guys, but even like the filming of it, the music, paid some local guy to come up with that music. Yeah, just the trickle-down effect. It's yeah, significant. So that's the car we built. That car is actually sitting right now in my garage here in Melbourne, and I'm about to strip it down and pull all the batteries out. Those batteries are for sale if anyone wants them. It hasn't done much more work than just what you saw there, and so I've got them advertised. And it's the thing that was the biggest problem with that particular vehicle was carrying so much weight to be able to get the range. And because of that weight, you lose performance, you have to bolster up springs, you've got a heavy car. And so what we learned from it is really swappable batteries are the way to go, and not the better place model of a standardised pack and all cars being standardised and going through some like a car wash and having the whole pack done. What we came up with was small batteries like a flashlight, and you load in 6 batteries if you only want to do a route of say 50-60 kilometres, and you can load up 20 batteries if you want to go a lot further. I designed those batteries so they could be stacked on a pallet, and they matched the pallet and they would interlock, and you could so a fleet operator could in fact get a pallet of batteries. So if they had a small truck, put in a pallet of batteries, travel 300 or 400 kilometres to another depot, pull one pallet out, put the next pallet in, so the turnaround time is negligible. You have a level 3 charger at that depot that charges up that pack, and the next vehicle that comes in just picks up that one, and so you're sharing your batteries, the investment in batteries, you are sharing it around as many vehicles as possible, and you are only running vehicles on the amount of batteries that they need. So you are maximising that investment once again. So that's the next stage, and this car is going to get those swappable batteries. I'm hoping to put lithium polymer batteries in this, and as soon as I find someone who's willing to pony up the cash for that, and we should be able to get around 700 to 800 kilometres out of that car. And I want to put it in the Global Green Challenge this year with those lithium polymer batteries in there, and that will be a world record, and we will do everything we can to promote that globally. If I can get Australia Post or Star Trek Freight, which has now been bought by Australia Post, to purchase vehicles, I think I've convinced them that if they have the vehicles, they might as well put them in the Global Green Challenge and get as much media exposure as possible. And so if we can get a convoy of vehicles, that's the idea, a convoy of vehicles, electric vehicles coming down from Darwin to Adelaide in front of the global media, and see if we can get in a couple of world records in there. One of the things I also wanted to do was to do the fastest road legal speed run using electric vehicles. So you have a vehicle come in and it's just a quick pallet swap and it's straight out again. You have a list, a group of drivers. You have some kind of commercial freight on board. I thought of some kind of quirky thing like a case of mangoes being delivered from the Chief Minister of the Northern Territory to the South Australian Premier, and it'd be the first freight driven by electric across the country, and we'll set some speed record doing that, the fastest run during daylight hours or something like that. So, questions?
What size is your battery pack?
That one had a 33 kilowatt hour battery pack of 108, Ben said 107, 108 90 amp hour Thunder Sky, which are now Winston lithium iron phosphate batteries, and it weighed approximately 300 kilos or 250 odd kilos. Because we cut out the floor of the car, we had to do substantial fabrication. I've worked out that you don't do that, again, because you've got to do beam and torsion tests and a lot of mucking around. You've got to buy a second chassis, and so you can compare it to the first chassis and all of these things, which we ended up doing, but yeah, in hindsight, a Mitsubishi Lancer or something similar would have been a better car to do a conversion on than the Honda Civic, but you learn these things as you go along.
You said something about the motor that you're using, putting out about as much power as a V8, but I take it you're using 2 of those motors. They're in-wheel motors, aren't they?
No, they were originally conceived as an in-wheel motor, but the research required to get it in wheel required another couple of $100,000, which we just didn't have. So we said, okay, well, let's put the motor in under the bonnet, and then we'll build a transaxle to mount to it, and then run out of the car's original differential. But that motor is stackable, and so based on the success of that particular exercise there, the company Ultramotive got bought out by Varley Electric Vehicles, and that there was a couple of motor designs that I actually said that I wanted based on potential customer surveys and operating this car. One was a smaller, lighter version. You don't need a motor that powerful, that big. And then run through, whereas that one didn't have a gearbox, it just had series parallel shifting in the motor, in the windings. But they've built a double motor, so you've got two of those motors together, which produces 1,000 Newton meters of torque, and you can imagine that from 0 RPM, and then an overdrive gearbox, just phenomenal performance. And they put that in a what's known as an SLC superlight racing car, which that particular chassis won the US GT Championship last year. And so they've built this really high performance car that will blow the Tesla off the road. But they've had all kinds of little niggling issues with the temperature control with the car, that it still hasn't been driven in anger, but it's been certainly taken to quite a few locations and shown, and it's a beautiful piece of engineering, but it's just not quite there. But the last time I talked to the guys, they've modified the motor so that it now has oil cooling, so that helps.
Is that oil cooling of the controller or of the batteries?
No, of the motor itself, inside the motor. Our controller, the controller we use there is glycol cooled, and the batteries are only air cooled. That particular battery pack is air cooled. The new battery packs that I've designed, the little small cubes, they've got 4 fans in them and a whole heap of temperature sensors. But you really, if you design the thing right, you shouldn't be overheating batteries anyway. That's just to idiot-proof them. But if you have the proper, if you're not trying to do something silly when you're charging them, you're just charging them at proper scheduled rates, and you're discharging them within the design parameters. You're not trying to drive the car too hard or something, then you should never need the battery cooling anyway. You'll notice quite a few shots showed the Tesla with big fan at the front blowing. They had quite a lot of temperature problems. That road surface, it was really quite hot. The road surface was probably over 50 degrees centigrade, bitumen, and we had no temperature problems at all, but they had some temperature problems. So it shows an Australian built car for Australian conditions. I should say that. Yeah, so any more questions?
What voltage are you running that?
The top of charge voltage on that was 450 volts. Nominal was around 400 volts. I have since dropped back the design such that we're now at 300 volts, 300 volts nominal, because it was so difficult to find all the ancillary systems to go with a 450 volt system, or you're just wasting electricity to keep on stepping down. Every time you change voltage, you're wasting power. So, so what we've got is 50 volt batteries, and then you connect them in series, 6 of them in series to give you 600 volts, and then you start to parallel them if you want higher amp hours, but you keep it at the 300 volts. And that way you've got people only working with a module which is 50 volts. So, and I've tried to make touch-proof terminals by having hidden Anderson plugs, so you actually have to kind of put underneath in there, and nothing goes live until the BMS is connected to the main vehicle. There's all these foolproof things in there. There's the air vents only open on a temperature sensor. There's water sensors in the batteries. Every possible way to make it so that that people with no skill in electric vehicles can run an electric vehicle. That was my objective for that. We built a second car so that at the end of that you had these pictures of this schematic of this buggy type thing. Well, we've now got that, and that was supposedly finished at the end of the year, but end of last year. But you know, with these things, you're constantly tinkering, and that is based on the quickest solution was to get a brand new Brazilian-built Volkswagen chassis, floor pan, and then I got a Myers-Manx fiberglass beach buggy body, one of the new design ones that has a roof and It's a 4-seater, and put that together, and then it's got swappable batteries that that go in that. Is this working or not? You'll probably find this interesting. I threw out to, I've contacted over 300 of Australia's largest businesses, energy companies, transport companies, and the only two that have in fact taken me seriously is firstly is the Australia Post Star Trek group, and the second one is Linfox. And other than that, everyone from Gina Reinhart through to your local law enforcement agency won't even return my calls. Not interested. But what I wanted to show you was projects. Projects. There we go. My glasses. So that's that car. You've seen that one. That's the second one, the Joey. So fully electric, designed for something like surf lifesaving, mining industry, ADF, and it has, this side here has removable batteries. So it has a couple of batteries that are in here and in the back, and it's got the original Volkswagen gearbox, and then just a cheap industrial motor that's been rewound for 300 volts. And yeah, and then you put in 6 batteries as minimal, and then if you want to load up batteries or hot swap them, quick swap them, then they load it to the side. This isn't the actual product, but that's what it is, what it looks like. And yeah, hopefully I have that on the road in a couple of months, something like that.
What sort of drag do you get from headlights like that?
Well, it's not designed to be a high-speed unit, this particular one. If I was an engineer, I suppose I could calculate the drag on that. But for, let's say Wilson Security is using these to patrol the grounds here and the car parks and everything like that, their average speed is going to be about 45 kilometres an hour. The drag would be negligible. There's probably more drag coming from the no windows, no sides, the vacuum created behind the windscreen. Obviously, if you're going to do highway runs, then you're looking at a completely different style of vehicle, like the Honda Civic there, which one of the reasons why we did choose it is it's very nicely aerodynamic. You've seen that one there. So when I'm talking to Australia Post, one of the types of vehicles which really suits conversion to electric well is the front-wheel drive Renault. And it's got, they could either take a pallet in the back of batteries, but more than likely they'd be just loaded up underneath it. After the seal, it kind of goes up significantly underneath. There's almost 200 mils of space, and you could get all the batteries in there to get about 100 kilometre range out of that vehicle. This is something I tried to sell the idea. I contacted Coca-Cola and others who have the license for Jim Beam and things like that. So, well, what if we got this old 52 Ford truck and we did the reduce, reuse, recycle type concept, and we loaded it up with these, and then we parked it out front of Bunnings, and we have Jim Beam on there, sporting events or something, at motor shows. This would have a crowd of people around it if this was electric and it had some thumping great electric motor under the bonnet that was chromed. So far I haven't had any takers. I've actually found the vehicle. There's one that someone's just brought over from Idaho. It's even got Idaho number plates on it. It's a really cool truck, but no takers yet.
Not that one in the middle, is it?
Sorry?
It's not that one in the middle, I was going to say it needs to work.
No, it's not that one, but it looks about the same. He'll sell it to me for $4,000, and then I'll have to put another $25,000 into it to make it look like the yellow one. Yeah. That's the buggy there. I I've talked to companies like ARB and the various transport and mining companies about a truck which is fully electric, and this truck has what I call near wheel motors, and it has both the original diesel motor and it has electric motor, so it's 4-wheel drive. And what you do is you can use a dog clutch, disengage the rear wheels, idle the motor over and charge and spin the electric motors. So it is both a 4-wheel drive, 2-wheel drive, either electric or diesel, and it's you can sit and generate, so it's a mobile power plant. And you can also do drag charging, and every time in regen braking, whole range of things. And I wanted to use one of these in wanted to drive the buggy down the Strzelecki track and have this as a support vehicle. Haven't found any takers. There's a group of motorbikes that are celebrating the Yamaha Tenere 20-year anniversary or something, and they're coming down the middle of Australia, and I wanted to tie it with that, but no backers. And racing cars. Done all the numbers. We can compete competitively at Bathurst with regards to circulation times, and with swappable batteries. We talk lithium polymer batteries that pop out the bottom when you come in for a pit stop. This is actually a competitive car, and you would think that companies like Virgin Mobile or someone like that, who are already sponsoring petrol cars in these types of events, surely they would get more mileage out of this. So far, no takers. So I took that design and thought, well, okay, let's turn it into a police car. So,
have you had any feedback from the authorities, or whoever, about those sort of easy swap batteries that have a road chassis? What's the safety? What's their opinion of the safety around that sort of thing?
Most of the work we did was up in Queensland, and we worked. Firstly, we had on board our own vehicle safety engineer, and so he was registered by the Queensland government, and he's licensed to do trucks and buses and cars that had conversions done. So he advised us the whole time. Secondly, there are new standards that have been written with regards to electric vehicle products, and Australia's trying to play catch up to Europe in that area, and provided the design is safe with regards to batteries aren't going to come flying out when you hit something, or they're going to explode if you go through a puddle or something, which is just I suppose Darwin Awards, but you just do it right to start with. There shouldn't be any issues. So if you're asking, are Vic Roads interested? They're only interested if you do something silly. But if you're doing something sensible, then no, it's not really an issue. There are basic rules that you have to follow with regards to where you put your contactors, how the thing shuts down. The vehicles that we've done have got inertia sensors in them, so if you crash into something or you roll over, anything like that, it shuts down the pack. If there's temperature sensors in there, water sensors, whole range of things. So it should be fine. Safer than a fuel tank. A tank full of petrol, I believe anyway. So that's one of the candidates for Australia Post or similar, just a Suzuki APV van. Lends itself nicely to electrification. They asked me, let's say we wanted 1,000 of them, what would you do? And I said, well, I'd bring up Suzuki and I'd say, look, I've got this little kit for you. So I've talked to a couple of car manufacturers, and they've said, we're not going to sell you a car without a motor because we can't get it off the production line onto a boat. But if you can supply us with an electric motor and a little battery so that vehicle can be driven off the production line and driven onto a boat, we'll ship it to you and then you can finish the job. So that's all we need. We need to license it with a small battery pack, a small box of smarts, it doesn't have to be the finished product, and a motor that bolts onto whatever drive system they already have in place. So that's still to be tested, but that's the concept. What do we got? Larger vans. Yeah, that's pretty much it. Just wanted to show you some of those pictures there.
Michael, if you have been over the years talked to the Rocky Mountains Institute, about 15 years ago, they produced plans for a vehicle which they were talking hydrogen at the time, electrics. Vehicle, but they were talking four-wheel drive, the size of an BMW X5, because at that time they were trying to leapfrog all the movements of the conventional car companies in China. They said, well, here's an open plan, anybody can build it. It's yours, you can do what you like. It was made out of carbon fibre, half the weight. It didn't have a steering wheel. It had away from the steering wheel. These people don't know steering wheels. We'll give them a couple of rods to use, driving a bulldozer. It just didn't get off the ground, but it's still available. Those plans are there, you can pick it up and do it. I'd be talking to them to see what they've done. I'm really interested.
I followed in the early stages, I followed Amory Lovins's work and others. I didn't find that they were going in the direction that I could sell within my budget constraints, firstly, that I could sell to companies that are at a current technological level, ideological level and budget level. There's certainly a lot of good stuff come out of Rocky Mountain Institute and others, and certainly the in-wheel motor concept is very good, and we would like to go that way. But when you look at where most cars are being driven, and especially if you start with fleet vehicles, it starts that weight really doesn't become an issue. And that may sound strange, everyone's trying to make things lighter, but really the lightness is only an issue for acceleration. Once you get up and running, if you've got high tyre pressures, it really, the rolling resistance isn't a big issue there. There's actually a graph. I did a survey of about 60 vehicle conversions and also did tests on my own car. In fact, I've got it here. Couldn't you spare me the time to do this? And it actually shows the relationship between weight and kilowatt hour consumption. And then I thought, well, if I can do that, then I can come up with a formula for an existing vehicle's energy consumption, so litres per 100 kilometres, and then work that to what would that car consume if it was electric. And it seemed to fit nicely. I haven't really, this is like all completely non-published stuff. This was, not in that one, EV reports. Australian Defence Forces, ADF EV, conversion of Land Rovers and Mercedes G-Wagons to electric hybrids. And if we look at what has been built and blah blah blah, where is it? There. Energy consumption by weight. It shows us that as your vehicles get heavier, really the weight becomes less of an issue. So if you look at the Tindo bus that's being run down in Adelaide, or you look at something that's really light up here, our car, I think this is the car that I just showed you in the movie there, was quite low, but that's the general curve. And so why would I worry about making a lighter vehicle for a commercial application? I might as well just use what's already being built, rip the motor out, and so that's why I say to someone like Australia Post, why not reduce, reuse, recycle? Let's convert what you've already got. You've already painted it. Oh, I unplugged it. Yes, I did that. So anyway, that's pretty much it.
You were talking about making it simple for the battery pack simple for the everyday user. The missile leaf on the next missile leaf that combines the controller and the motor in one unit.
That's clever, isn't it?
And the saved, I can't remember how many kilograms, but the saved quite a few kilograms doing it because you haven't got the cabling in between, you haven't got all the complications. I mean, they know the motor, they know the controller can all be pre-programmed. Just so as one unit, basically attached, not too many attachments to it.
Yeah,
That definitely simplify, because that's the biggest trick is getting this control, whatever control you buy, so you work with the name you got.
yeah. Well, certainly they can do that because they are, one company, and they can have, this is our in-house motor, this is our in-house controller. Controller technology is progressing quite rapidly, and the days of a 30 or 40 kilogram air-cooled Zilla controller or something like that, which was this big, have now been reduced to something that's only this big, and it's liquid cooled, and it's got enough smarts in it that it'll talk to a range of motors and a range of chargers and a range of battery management systems, such that it becomes a software programming issue instead of a physical or mechanical issue. There is lots more to come that we will see the auto manufacturers producing, but that's mainly for their profit margins. With regards to energy efficiency, like our controller and motor in that car are running at 97.5% efficiency. It's going to be 20 or 30 years before that creeps up by another 1%. With regards to the weight of that particular motor, the spinning mass was 28 kilograms. It's probably going to be a decade or two before that comes down by a couple of kilograms. Yeah, well, I would have loved to have bought the IP on that motor. I would have loved to have bought the company Ultramotive, but Varley Electric Vehicles bought them instead, and Varley Electric Vehicles then took a big stake of tritium as well, and they're producing this stuff for their in-house airport tugs and things like that they build, street sweepers and whatever, and also they're moving into the wind turbine market. So that's where the stuff is currently being used. All right.
Oh, well, I want to thank Michael for his presentation, and we'll continue the chat having tea and biscuits.
Yes. And while I've got the podium, as I say, all the batteries for that particular car are up for grabs, and the battery management system, and the charger, because I'm swapping them over for something else, and I've got another load of 60 amp hour batteries, brand new, never used. So if anyone's building an electric car and they're looking to buy batteries, they came from EV Power over in Western Australia, got all the receipts. They're kind of good to go.